All right, let's take a look at the Fun with Molarity activity. So it says first, open the simulation by pushing the play button, which I already did, and then check this out right here. There's the little concentration tester, and you can just drag it down into the solution. Right now it's 0 because I haven't added any of the drink mix. So it says add some drink mix until the concentration equals about 2 moles per liter. So I gotta go kind of slow because I don't want to do too much. Stop. Too much. 2.5. Okay, hang on. Let me try again. This is gonna be one of those annoying simulations, isn't it? Where it's like you want to be like a perfectionist about it. Maybe it's just me. Okay, close enough. So this means there are about 2 moles per liter. It should look like this picture. Okay. It says add more drink mix until you notice a color change. Okay. Ooh, it's getting much darker. Okay. Have you increased or decreased the concentration? So let's see, I'm going to make this in red. I increased the concentration, more moles of solute per liter of solution. That's the definition of an increased concentration. Now it says pull the knob on the faucet at the top of the screen until you have 1 liter of solution. Is the color of the solution lighter, darker, or the same? Pay attention not only to the color, but the concentration. So the concentration's 5 right now. And ooh, it got a lot lighter. And now it's only about 2.5. Okay. Describe how the color change relates to the concentration. So the lighter the color, the less concentrated the solution, and vice versa. So the darker the color, the more concentrated the solution. Evaporate the solution by pulling the faucet knob at the bottom of the screen. Evaporate the liquid until it's at the level of the last line on the beaker. Where am I supposed to evaporate? Oh, you're supposed to evaporate, not pull the faucet knob. So let's try this again. It was at about 2.5 or so. A little bit more. Okay, so if I evaporate the water, ooh, too much. It's really saturated now. Does this increase or decrease the concentration? So this increased the concentration. In both instances above, where you added solvent and you evaporated the solvent, did the number of particles of solute change? No. No, the number of particles of solute stayed the same. I never hit remove solute, and I accidentally used this knob. I didn't mean to. Now reset the simulation button and switch the solute to sodium chloride. Add NaCl to get a 1 mole per liter concentration. Oops, I guess it'd be helpful. There we go. You can't see color now, but tell me 2 ways you could increase the concentration of the solution. Add more solute or evaporate some solvent. Now try it. Pay attention to the moles per liter. So I could add this. That increased the concentration, or I could evaporate. That also is increasing the concentration. Did it work? Yes. Watch this simulation. What particles are now in the solution? So I already watched this, and Na plus and Cl minus are now in solution, separated. So just, oops, that's not what I wanted to do. I want to superscript this, and I want to superscript this. Extension questions. 6 molecules of sugar represented as a dot are dissolved in water. The picture below represents the solution at the molecular level. Which of the following pictures best represents what you might see? So they spread out because they're in constant motion. Using the pictures below, tell me the order of the beakers from lowest to highest concentration. So this is lowest, and this is highest, and this one's in the middle. If this is our original picture, which beaker in the picture above shows half the concentration? B. How would you describe the concentration of particles in beaker C compared to beaker B? Well, beaker B has 3 moles per liter, if each is representing a mole. And beaker C is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So it's 4 times more concentrated. So if that one was 3 moles per liter, for example, this would be 12 moles per liter if each dot represents a mole. Summarize what concentration means using the terms solute, solvent, and number of particles. So concentration is the number of solute particles dissolved. Concentration is the number of moles of solute particles dissolved divided by the number of liters of solvent. So higher concentration equals more solute per liter of solvent, and a lower concentration equals less solute per liter of solvent. There you go. Hopefully that helps you understand.